In this video, we are going to practice using our exponent rules to simplify expressions. For many of these examples, there's going to be multiple ways to arrive at the same answer. So your reasoning may be a little bit different than mine. Just make sure that our answers match up. My choice for this first one is to distribute the outer exponent. It's a power to a power, so I keep my base and I multiply the powers, which gives me -6 and x to the -14th. Now, I do have like bases, and I also have negative exponents. So I'm going to make my exponents positive by flipping the numerator and denominator. And now I'm going to use the division rule where I keep my base and I subtract the top exponent minus the bottom exponent. My final answer is x to the 8th. I'm going to start in this one by distributing this outer exponent of 4 to the two factors inside. The first factor is 2, and you might find it helpful to make this 2 to the first power. So I distribute this 4 to that 1 and to this 3. I'm just going to recopy this 3x, and this would become 2 to the 4th power. A common mistake is that kids will do 2 times 4. No, you keep the base and you do 1 times 4. And then x to the 3 times 4 would be 12th. I'm going to clean up 2 to the 4th power. You can use your calculator if necessary. It would be 16, and I have x to the 12th, and then 3x out front, right? Now this is held by multiplication, so I'm just going to multiply the 3 times 16, which is 48, and then I have x to the 1st, and this is all multiplication, times x to the 12th would be keep my base and add my exponents to get 48, x to the 13th. For my next one here, I have to start in the numerator by distributing this outer exponent, which will become x to the power to a power, I multiply, x to the -6, y to the +6, and I recopy the denominator. Now, as I look at this, I am looking for like bases. So I have a set of like bases here and a set here. So, a couple ways again that I can handle this one. Your choice may be different than mine. I'm going to choose to do the division rule, which is keep my base. Where do I keep it? Up in the numerator. And I take the top exponent minus the bottom. So I'm doing -6 minus 5 for the exponents, which would be -11. Keep my base, subtract my exponents here would be y to the 0. Now, y to the 0, anything to the 0 power is 1. So what do I get? Well, I have a 1 up in the numerator, and this x to the -11th needs to become positive. I flip it to the bottom and the exponent becomes positive. I know I'm finished because all of my exponents are positive and I have no like bases remaining. In number 4, I suggest you pause the video and try it on your own. As you attempt this one, there's 2 ways you can do this. You could clean up the inside because you've like bases, or you could start by distributing the outer exponent. It's your choice. I'm going to distribute the outer exponent first, because usually that's what most students choose to do. Okay, so I'm going to pick, let's see, a to the 6th on the top, power to a power is multiply, b to the -3rd. In the denominator, this again would be 2 to the 1st, so you keep the 2 and you do 1 times 3, so 2 to the 3rd, a to the 9th, 3 times 3, and b to the 6th. Now, I'm going to start cleaning this up. I will take my top exponent minus my bottom exponent for each of my like bases. So the a's and then these b's here. All right, and then this 2 to the 3rd on the bottom would just stay on the bottom, but 2 to the 3rd would be 8. Keep my a on top and take the top minus the bottom. 6 minus 9 is -3. With the b's, top minus bottom would be -3 minus 6 is -9. Now, I have 2 negative exponents, which is not okay. They're going to drop to the bottom to become 1. And where did 1 come from? Because the coefficient's always understood to be 1. 1 over 8a cubed b to the 9th. Again, not the only way to do this problem, but one possible way. In the next one, again, pause the video. Check your answer when you're finished. My first step is to multiply these powers together. So 7 times 1 is 7, y squared times y to the -4th, keep my base and add the exponents. Same with the z's. Now, I'm nearly finished, but I spot a negative exponent, which is not okay, so I've got to clean this up. How do I do that? Well, that's going to flip down to the bottom, The 7 and the z to the 4th stay on the top, and y squared drops to the bottom. Okay, in 6, I am looking for like bases. The s's are like, so keep my base and subtract the top minus the bottom would be s to the 1st, and that kind of looks like a 5. So I think I am actually going to switch to a cursive letter, so it looks like an S. T, keep my base, top exponent minus bottom would be 4 minus negative 5 would be positive 9. And here, this is just a 1, r to the 0, so this r to the negative 2nd flips to the top and becomes positive r squared. I have no more like bases, so I'm finished. 7, several ways to approach this. You can multiply your numerator and denominator together and then simplify, or you could try simplifying first. I'm going to multiply the numerator together and denominator, pause and check that part. Here's what I get when I multiply. Now I'm going to use my division rule. Well, 8 divided by 162, that just reduces the same way fractions always do. So if you're not good with fractions, do math and enter on your calculator. That reduces to 4 over 81 because 2 goes into both of them. The x's, keep your base up top. Top exponent minus bottom would be 3 minus negative 1 would be 4. 2 minus 5 would be negative 3. And negative 2 minus 6 would be negative 8. So I got one more thing to do yet. I've got 2 exponents that are negative, so I need to clean those up yet to become 4 over 81. X stays where it is. Y drops to the bottom and becomes positive, as does the 8 for a final answer. In this last one, again, I encourage you to pause the video and check it on your own. The only thing I would say is this 4 needs to be distributed to everything up top before and everything in the bottom before you multiply your 2 fractions together. Here's what I get when I distribute that outer 4 to the second fraction. Now I'm going to proceed to multiply numerators and denominators together. Pause, try it, and check. Here's what I get when I use the multiplication rule where I keep my base and I add my exponents. Please notice that coefficients, 3 times 2 to the 4th would be 3 times 16, which is 48. Multiplication of numbers works the way it always has. So now you need to clean up using your division rule. You check and see if there's anything that goes into 48 and 27. And again, if you're not good with fractions, math enter on the calculator. This would be 16 over 9 because 3 goes into both. Keep my base. For the D, 6 minus negative 11 is positive 17. And then keep my base, and 15 minus negative 11 is positive 26. So here is my final answer. The final thing I'll say to you is that it is very easy to make an error in these problems. You need to practice, practice, practice so that the rules are very clear in your mind. If you have any questions, as always, please reach out to me.